Hi, I'm Eric. I've been on the team for 4 years now, and I've been doing PulseCrew for this past season and the season before that.
Hi, my name is Rain. I'm the Vice President of Engineering. I've been on this team since freshman year. I'm a junior now, and I've done PulseCrew for the past two seasons.
Hello, I'm Rachel Kim, and this is my second year on the team, and I'm from the mechanical department. My name is Ellen Kim, and I'm also second year in this team, and I'm also part of mechanical. Okay, so what is PulseCrew? We are a group of students that go around the competitions and assist other teams in the pits. We not only help with mechanical and software issues, but we also have members from like the electrical and pneumatics department to help address other issues as well. PulseCrew is a great opportunity for our members, for our team, especially the newbies, because not only they're able to retain information from the build season, but they're able to gain new knowledge as they assist other teams. Members are able to have a boost in confidence as well as grow their leadership skills through the experience, and as well as have so much fun because we get to interact with other teams and make friends. There's some similar programs. Most well known is Citrus Service from Citrus Circuits, Team 1678. And there's also closer to our home are Robo Tigers Emergency Service Squad, artists from Team Robo Tigers from 1796. And lastly, we have Solving Ordeals with Steel, SOS from Steelhawks Team 2601. So, the history of PulseCrew. PulseCrew did not exist before. We had two separate divisions. The Fix-It Crew, which assisted with mechanical issues, and we had the Mobility Missionaries, which helped other teams with software issues. So these two divisions were separate, but we've noticed that during competitions, as we help other teams, especially the electrical team, electrical members, and the software mobility missionaries, they work closely with as they help other teams. So it was unanimously voted in 2022 by our team for PulseCrew to be established. So we combined the Fixit Crew and mobility missionaries together to be now known under PulseCrew. So we were able to answer more than 100 calls from the regional in 2022 NRC regional. And last season, the 2023 season, we were able to assist in the Long Island regional as well as the NIC regional. And so for our post-growth philosophy, we want to make sure we are kind, humble, and respectful so that we can approach our teams. And so we can do is, let's say we see a robot with an issue on the field, we can approach them and ask if they would like assistance. But we want to make sure that we check on teams at appropriate times. So we don't want to go up to them after they were just disabled and ask if they want assistance because they're most likely busy and fixing their problems or fixing their own problems. So we want to give them more time, and if they still have issues like in the future, we might want to go approach them. And another example can be, let's say we have an alliance with a robot, but we don't want to check on them like 40 matches before because that is like way too early. So we want to keep and make sure to check them at appropriate times. And we want to also make sure that some teams may not want help. So if we ask if they want assistance and if they decline, we want to make sure we respect their decision and they would like to probably build up on their own experiences. And after we assist the team, what we can do is show the location of our pit if they want help in the future or if there's any further questions relating to the issue they had. And another thing we can do is by providing our contact information, such as their email, address on a business card, so that if they want to contact us during other competitions or after competitions about any questions or issues they had, they can contact us. And also remember that we are students as well, even though we're part of Post Crew. We won't know answer to every problem out there. And so remember that there are RIs and CSAs and FTAs that are there if further assistance is needed. So for instance, one time a team wanted to convert CAN wires to PWM wires, and Post Crew never had the experience or had not did not have the knowledge of it. So we were assisted, and from this experience, we also gained new knowledge that we can apply for our own team and other teams as well in the future. So this is a packing list for competitions that are nice to bring, but this is not the full packing list. So some teams may not have extra batteries, but our team does. So we would bring extra batteries to prepare ourselves just in case there might be emergencies, or if other teams want, if they want to borrow our batteries, we can lend their batteries. And since we have multiple chargers, we will be able to charge other teams' batteries if needed. And we also bring some stock such as one by one aluminum and thunder shaft. And we also bring spare parts such as like the whole intake that we want to replace or the arm. We also bring 3D printed mounts that we want to replace because they can break during the competition. And we also bring extra tools, so they can include anything that can be used to fix the robot, such as drills, Allen keys, wrenches, strippers, and trimmers, and anything that can be used to fix the bot. And bringing extra tools can be helpful. So, for instance, let's say a team wants to borrow our tools, then we can lend some of our tools, but we'll also have enough tools to help fix our own bot. And one tool that we like to bring is the hot glue gun, but this is also personal preference. Some teams may not like to have hot glue guns used on their robot, but what we use hot glue guns is when, for instance, we want to hot glue gun the end of our encoder wire or the mounts to the Spark Max. And this is also very useful because hot glue guns can be used as insulators, which are good for wires. And also, we want to bring Ethernet cables of various lengths because some lengths can vary up to 7 feet, 6 feet, and short as a foot and a half long. And different teams may use different length Ethernet cables, and also our team does that as well. And we also bring soldering kits that can be used to resolder or solder wires, CAN wires, and power wires to the encoders, and other teams can borrow our soldering kits for the same purpose. And we can also solder, let's say we want to extend LEDs or fix broken LEDs, we can use it to solder them. And we also bring a test board that we built before that has all the basic control system components. So we can test some components such as the radio and check if the radio functions properly. And we also have a CSA flash drive that contains, let's say, the WPI lib, the Rev hardware client, the Phoenix Tuner X that can be used for our teams to update a firmware, and other teams can borrow this flash drive to update, let's say, their RoboRio to the latest version using the WPI lib. And we also bring bumper material, which includes plywood, pool noodles, staplers, fabric, and paint, so that we can build or fix bumpers for our team and other teams. Because some teams may want to rebuild their bumpers, or their bumpers might have issues with their sizes. And like mentioned before, we bring spares for all the control system components. So it can include like the VRM, the RPM, and Spark Maxes. So we can lend Spark Maxes on like motors to other teams that need it. And we will also bring pneumatic system components such as like air tanks, solenoids for any teams that want to borrow.
So I guess common mechanical problems that we usually see are just like really unbuilt bumpers or like bumpers that aren't very secure. For unsecure bumpers, usually you can drill a hole, attach a bracket, and then put a bolt through it, and it usually works. Just like a second attachment point, so the bumpers don't fall off during match. And for unbuilt bumpers, we just spend like a day with the team, several hours, and we make them bumpers. Uh, I think four-piece bumpers, like the around the corners, are usually the easiest, but it really depends on like the specific robot. That's why we bring buffer materials. Like sometimes they're cut down to size, just to make it easier to take. So like 5 inches. Which yeah. Um, Gearboxes sometimes they are broken, sometimes they're not assembled. We help replace them if they're broken, and we put them together. Yeah. Some teams will come to competition with just a drivetrain and they're trying to build a whole robot. So gearboxes are like pretty important in that. We lend out a lot of tools and parts. Sometimes a robot is a little too large, so we need to cut them down. We help with that as well. Some tools that we bring, I guess mostly bolts. We have a lot of bolts that we bring. Yeah. Um, for pneumatics, there's always the most usual problems are leaks, as I think everyone expects. For that, you really just have to push in tubing and just look around. If you hear a sound, that's really nice. That is more easy to detect, I guess. But when you really don't know where it is, we do something called what we call like bubble testing, which is essentially just a water bottle and you put dish soap in it and you shake it up. So there's bubbles. And when you apply the liquid on like the fittings, you want to put it around the threading. You want to put it between the connections, so brass fittings on the compressor, and then the fittings on pistons around the tubing. Um, well, if they like start bubbling up, then you know that you have a leak there, and usually it's either it replace or you have to tighten it. We also last year had a bunch of uncalibrated manual release valves where some teams didn't know how to calibrate them. So we have calibrated manual release valves that we bring for replacement. They're just calibrated to 125 psi, which meets the first like regulations, I guess. For yeah. And then so some last year I think Anymark also had manual lease valves that kind of turn to the left instead of the normal turn to the right. So teams were confused by that. So we were like, okay, we'll just replace it if we don't know what's happening, because we know that ours works. And it's like they can get on the field faster. Okay.
So common problems and solutions for the electrical part. So one of the main issues we see are related to the battery, where batteries are uncharged, they have untaped terminals, or they are not strapped down. So our team, as mentioned before, we lend and also charge. We lend batteries for other teams as well as charge other batteries for future use because we also have extra chargers. And for untaped terminals, we also tape them for extra supports. Also, we provide Velcros to other teams because many other teams they might not have secure batteries. So we provide Velcro so they can strap the batteries down so they can be nice and secure during competitions, especially when there's like a hard impact with other robots. There's also another issue we see are loose connections with wires. So we can make sure we can do tuck tests. We can use like check where there could be a disconnection, such as in the pins, and we can use the clips, especially the Anderson clips and the PWM clips, to make sure the connection is there because we don't want any electrical problems during the match. And we can also check for faulty wiring. So like if the wires are disconnected, they're cut, they're exposed and open, we can make sure to check for these wirings for connection. And also another issue we see commonly is like damaged electronics parts. For example, in the 2022 season during the NIC regional, we've seen a burn of DRM, and so can lend extra components. This can even range from like power poles, Anderson clips, PWM clips, or to like the control system components such as the VRM, the PCM, or like Spark Maxes. So yeah, we also lend components, and we also test the parts using our test board, as we mentioned before, to check for if to detect or diagnose any errors with these components, such as you can check like the reel. I mean, sorry, the radio and the reel also works. So we also sometimes see incorrect setup. So like that was mentioned before. So some teams may not have knowledge of how to build the electronic system. So we can help them wire all the components together from scratch and explain how all the components are related and connected together. And another thing that was mentioned before is updating firmware. So everything from revs such as the PH, the PDH, and Spark Maxes can be updated using the Rev hardware client using the USB port. And we can also update components from CTRE through the canvas. And we also see motors overheating. So for instance, when we competed in China, our motors were very overheated, and what we can do is by using compressed air to cool it off, because motors overburning is never good and can influence other components as well. And what we also see is CAN errors. So if there's CAN errors, you can do all the basic wire testing, such as a tuck test, and check if there's any exposed wire, if there's any wire cuts, or if all the clips, such as the PWM clips, are there. And sometimes if there's issues, we might not be able to find the issues, and this can be due to metal shavings and debris to strap down all the wirings. So we don't want any wires to be touching the motors or any part of the bot that is moving, such as the arm or the intake. So we can strap them down all using zip ties.
Anyway, so slightly a continuation. When you really don't know what's happening or like what's wrong with your robot, I think these help a lot. Um, a lot of electrical components have satellite status lights, which say like your Rio has status lights, PDP, all of the above. We have a compiled sheet of status lights. It's like linked. This is like a photo of some of it. There's more when you scroll down. So we have the Robo Rio, we have the PDP, BRM, radio, and then like talons. It's a really nice reference sheet because you can just open it and you know that the part you're looking for is probably going to be there. And you don't have to search it up because some places they don't have Wi-Fi. Like Battlecry, we're in the basement, and I do not get service down there. And the sheet's really nice because we can put it offline, and we just reference it whenever our robot breaks. Um, Driver station tells you about CAN errors, so that's really helpful. Sometimes they'll list out like which CAN IDs have the error, so it's easier to troubleshoot. You can go to that like specific Spark Max or like that section, which is also like a good lead into tracing wiring. If you know what your wiring is, like you know where one part leads to another, say on the CAN bus, you know that CAN ID 20 leads to CAN ID 21, it makes it easier to troubleshoot because you know that if CAN ID 20 is like down and CAN ID 21 is fine, then it's like, I don't know. That happened to us and we were really confused. But it's like, it gives you a point to start at. Tracing wiring also helps you check connections, so you can push the connections together, check that the clips are still on them, so they're not going to pull out immediately. Check for exposed wire, so same as before, exposed wire. Usually, you should just tape it. It's like how we try not to put wire near moving parts so they don't get tangled up in that. So spinning parts, moving parts, yeah. That also leads into that making sure your components are secure, making sure that your wiring is tucked away into places that they won't get cut or crimped. Um, yeah. So you also should check your breakers and fuses to make sure that you didn't pop them. Breakers over time, they can be reused, but they get shorter each time that you pop them. And if you're drawing that much current, that's a little bit concerning. Fuses also protect your components from like blowing up. So a blown fuse isn't really like great to have on the robot. You should probably replace that so it can protect your components. So far.
Alright. So not every issue is a mechanical issue. Um, so here's some common software mistakes. Most teams that I help usually have like code copy from other people or like don't have code at all, right? So no shame to that. It's just that I know some teams allocate more time to actually building the robot. Yeah, I don't have time for software, but that's completely fine. That's why us mobility missionaries or well now are part of PulseCrew. That's our job. So some common software errors. Well, it's really frustrating where your mechanism is like not moving as you anticipated, right? So first things first, is the motor controller configured? We can if it's not configured, we have that flash drive we always bring around with the Phoenix tuner and all that stuff. That's at least once per competition. That's always going to be borrowed around. Well, are the motors plugged in backwards? Are your controllers wired correctly? Like some I've seen a couple times where teams have like their drivetrain motors like not aligned the correct way, so they spend the whole match spinning in circles.
Sometimes they're also like, if you have the old motor controller boards, if you wire them backwards so motor goes to PDP, it actually lets the power through to your motor. So as soon as you turn on the robot, the wheels just start spinning,
Yeah,
and that's not good.
not very good. Um, and WPI Lib also has like a lot of like methods and functions, right? And you should be very careful about like you should be able to understand what you're passing through those functions. Otherwise, like it makes debugging really difficult. Make sure to always double check your logic whenever you use a function that's not yours. Um, do you oscillate often? You should double check your PID. Well, actually, tune your PID values to make them like more consistent. Because if your PID values are too high, it causes overshooting and therefore oscillation. And well, this is just some syntax errors. Make sure your imports are correct, especially if you're copying code from like other teams' libraries, other teams' code. You make sure because every file is like has a different inputs, different imports. Sorry. You want to make sure you have the correct imports and like your program can actually build. Incorrect declaration. Sometimes the teams like don't declare like when you're creating objects aren't declared. This is more Java specific, but sometimes the objects aren't declared, and that does cause some issues. But those are really easy to catch. Um, Accessing the wrong sensor or object. This one's a bit tough to see because you don't really know if that's a electrical issue or a software issue. But I've seen this a couple of times where the constants are named efficiently. If the constants are named efficiently, then it's really hard to like actually debug your code. Um, yeah, and are your inputs correct? I just copied a couple of times.
So how this can apply to other teams is first, like mentioned before, we want enough spares so that if anything breaks or anything that is about to break, we can replace them soon enough before matches. And so what we have is a pre-match checklist to check if everything is there, everything is not broken, and ready for the next match. So first, everything that you like to check for another team's robot, you will want to check for your own team because anything that is beneficial for other teams will be beneficial for your own team. And another thing is to check for things that you know might break or come loose on the robot. So for instance, let's say you know this shaft will bend, easily bend, then you can always check it before it bends or causes any major problems during the match. And also make sure to tighten nuts and bolts. So as time passes on, the nuts and bolts sometimes tend to come loose. So before matches, you want to tighten every nut and bolt that comes loose to make sure they do not fall off during the match. Oh, so we also have to check for wires that may pull out, like doing the tug test, and also check the overall, making sure that all the wires are put together nice and secure, so that there will be no electrical issues. Also, to check for a fresh battery, you have to make sure that the robot can have full power during the matches, and they won't suddenly run out of battery, or they might be weak if the battery is not full enough. And we can also zip tie the battery housings in the end. You can put it between the wires and put it over the housings so they're nice and secure. Well, so, even though they don't come off easily, we like to take this extra step to make sure everything is nice and secure. Um, Also, we can check for retaining clips and making sure that the connections are put together correctly. Because for our team, we've experienced during champs for last season, during the first opening bracket, our robot was disabled because our clip for we had retaining clips on, but then the connection for the housings weren't proper, so the retaining clips eventually fell off, and then the connection eventually came loose. So we eventually became disabled. And so, in order to make sure nothing like this happens in the future, and to make sure that these are slid on properly and the retain clips are on properly, nice and tight. Also, to check for bumpers if they're secured because
Is like it's public, so you can just look at it whenever. You want to make sure that your robot adheres to it. It's a really quick. It's a list of things that you can check on their robot, and it's really helpful so they don't fail inspection. It's not on here, but like yeah, it's a component that's part of the control system. So you have the Rio, the PDP. So everything can just be connected to like a battery, and you can attach motor controllers, motors, or take them off. There's a Rio on there, so you can plug in certain components, see if they like work. The RS sensor sometimes we use to test distances. So we'll plug it into the test board, we'll plug it into the RoboRio, and we're gonna tune it so we can put it on the robot. Like really quickly.
Yeah,
we have to tune it on the robot.
we have all of that like in a wooden board, so we could just
I
take
think
it.
I've seen it before. I think I've seen it on like a cart and just
Yeah.
rolling around. At first when you said test board, I thought like you plug something in and it would give you like a status of like every single item or something. And I was like test board. So
Yeah,
it sounds
it's
like custom
yeah.
engineered.
It's not quite. It's just like the entire control system on one board. Yeah.
Everyone if we want to
Materials.
Yeah.
I would go to materials too. If
And you said you still have time to go to materials.
yeah.
His presentation ends in what, like 5-ish?
I think he's gonna be talking for a while, so probably like a bit more.
Something like that.
Yeah.
3:35.
Here.
Upstairs. You have my grade upstairs.
That's on your screen.
I am hoping leaving alone. I'm so sad.
That's it.